All right, let's just dive right into this structural explainer. Look, as construction professionals and property experts, we've literally all walked onto a site and spotted a cracked wall, right? It's pretty much the most common symptom of building distress out there. But today, we're going to put on our forensic engineering hard hats and figure out exactly how to read those signs. We want to know what's really happening beneath the surface.
To diagnose a building properly, we're taking a medical approach today. We'll start by looking at the symptoms, cracks and creaks, then the mechanics behind them, like settlement and racking. After that, we'll dig into the root causes, mainly soil and water. And finally, we'll wrap up with a foundation health matrix. Okay, part 1, symptoms, cracks and creaks.
So, the very first question we always have to ask ourselves when we spot a flaw is this: are we just looking at normal cosmetic aging, or is this a serious structural warning sign? Honestly, most cracks, they're really not emergencies. Materials just age over time. Drywall tape separates, paint shrinks, it happens. But when a crack actually reflects movement in a building's structural frame, well, that's when we absolutely need to pay attention.
And you can really see the difference when you compare them side by side. On one hand, you might have a super typical shallow crack right near a window frame. It's totally stable. It's likely just a surface level cosmetic flaw from, slight humidity changes or normal material aging. But on the other hand, you might see a clear, measurable structural failure, actually tearing right through a concrete slab. The sheer width and depth of something like that tells you the structural integrity itself is compromised.
So, here's the crucial threshold to keep in mind: 5 millimeters. If you're looking at a stair-step diagonal crack, say in the brickwork or the foundation, and it's wider than 5 millimeters, which, by the way, is roughly wide enough to wedge a coin into, that is a high-severity indicator of active foundation movement. Remember, cosmetic cracks are usually just hairline. When you start seeing gaps you can literally measure with a ruler, you're dealing with serious structural stress. Moving on to part 2, mechanics, settlement, and racking. Now that we know the symptoms, we need to diagnose the physical forces causing all this distress. How is the building actually moving? Well, this brings us to differential settlement. That's when one specific section of a footing drops lower than the sections right next to it. Uniform settlement, where the whole building evenly sinks just a tiny bit, is usually totally fine. But differential settlement, that puts immense shear stress on the walls. The structure is basically being stretched and pulled in completely different directions. And since materials like brick and mortar are incredibly rigid, they don't bend, they just break under the tension. And the real danger here involves a concept known as racking. When that differential settlement happens, or even when really high lateral winds hit a building, the actual square geometry of the framing gets completely compromised. Racking is basically the technical term for when those perfectly square or rectangular wall frames are forced into a distorted, tilted shape. Think about how this builds through a structure like a domino effect. Imagine a simple wireframe graphic of a house. First step, a foundation corner dips down into the soil. Next, because that specific corner dropped, the attached framing gets pulled right down with it, distorting from a perfect rectangle into a slanted parallelogram. And finally, because of that shift, all the perfectly square cutouts inside that frame, like your doors and windows, suddenly completely lose their alignment. And that leads to a ridiculously common symptom. This parallelogram effect is the exact mechanical reason why doors suddenly start binding and sticking in their frames. I mean, if a door used to close perfectly and now it scrapes against the floor or flat out refuses to latch, it's not because the door magically grew, it's because the frame around it has racked and is literally no longer square. All right, part 3, root causes, soil and water. To find the actual disease and not just treat the symptoms, we have to look outside and beneath the building to figure out what's actually making the foundation move. Here's a massive site pro tip. Local soil conditions absolutely dictate foundation health. We're talking specifically about expansive clay here. In tons of construction regions globally, like areas with high clay content common in parts of Pakistan, for example, the soil basically acts like a giant sponge. When it gets wet, it swells dramatically and pushes the foundation up. But during dry seasons, it can shrink by up to 8% vertically, literally dropping the foundation right out from under the structure. That seasonal shrinking and swelling is a massive driver of differential settlement. So what controls the moisture in that soil? Exterior water management. Foundation failure almost always starts right outside the building. Things like poor roof drainage, missing gutters, or defective splash blocks end up dumping thousands of gallons of rainwater directly next to the foundation. that concentrated water either causes those expansive clays to heave on one side of the structure, or it literally just erodes the soil support right at the edge of the footing.
Which brings us to part 4, the foundation health matrix.
So this is the professional prescription. How do structural engineers actually monitor these forces? Well, when an engineer suspects active movement, they don't just guess. They use these specialized instruments called telltale crack monitors. You mount these securely directly across a masonry crack. As the crack opens, closes, or shears vertically, the red crosshairs on the device slide over a grid. It's brilliant because it allows engineers to track the exact rate and direction of the structural movement down to a fraction of a millimeter over time. It gives you hard, actionable data on whether a crack is actively moving or if it's totally dormant. To make this incredibly practical for you on site, we've distilled this engineering data down into a foundation health matrix. This is basically your definitive diagnostic tool. Got a hairline vertical crack? That's low severity. Just monitor it. Sticking doors or windows? That's medium severity. You need to check if the frame is racked and out of level. But pay close attention to these last two. A stair-step diagonal crack wider than 5 millimeters? That is high severity and means a professional audit is definitely required. And visible slab unevenness? That is critical. You need immediate structural analysis for that. Keep this matrix in the back of your mind before panicking over a cosmetic flaw, or worse, before accidentally ignoring a serious warning sign. And I really want you to take away the specific engineer's perspective. It's essentially the golden rule of this entire explainer. Cracks are a symptom, not the disease. Look, if a contractor gets hired to just patch up the drywall or tuck point the brick without actually fixing the drainage issue, that crack is simply going to return next year. The underlying source of the soil moisture or the bearing capacity loss, that has to be found and fixed first. Which brings us to one final, really important thought. Before you spend time stressing out over hairline cracks on an interior wall, go outside. Literally walk the perimeter of the property. Check where that rainwater is going. Are the downspouts actually extended? Is the soil properly sloping away from the building? Getting a handle on your water management might literally save the foundation. All right, thanks for joining me for this explainer, and I'll catch you in the next one.